Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of September 23rd this time around. So this week, a special week for you. If you've been watching these, you get to learn a little bit more about me, just a tiny bit. Maybe I talk about myself all the time and you know everything about me. I don't know. But it starts with the fact that I've had COVID this week. And so I've gone the entire run of the existence of that without having it. And now I've had it twice in 7 weeks. And I've been away from work for a couple of days. And just to keep people safe, I've come in the evening to shoot this video. And it's very much a morning person. I'm not accustomed to shooting these in the evening. So if I'm not as sparkling as usual, that's where that comes from. So that's the first little disclaimer that you get to learn about me. We'll have the other one coming up in just a little bit. So let's start. On the morning of the 24th, so the night of the 23rd into the morning of the 24th, the moon will look like Moon, Jupiter, Mars, and the moon will form a nice triangle. Well, actually, the moon will be in this region for a couple of days. So you can watch this. The moon will be 54% full. So we've got a waning moon. We'll have a pretty good moon for observing then the rest of the week. A couple of days later, the moon is about 1/3 full and sitting next to Pollux. Castor and Pollux, the twin stars in Gemini. So we're getting about 2.5 degrees, I think, is what it gets, which is bigger than a moon diameter. So it won't look right on top of it, but it'll be right in that region. Now, by the time we get to the end of the week, on the morning of the 30th, so a full week out from when we started thinking about observing here, the moon will be in Leo, and it will have waned away to the thinnest of crescents, about 5%. And it's really hard to see a 5% moon for most of us in the glow. You want to be out half an hour, 40 minutes before sunrise to try to catch this 5% full moon. The only reason I bring this up is because you maybe have been reading something about this comet that's coming around Tsuchinshan-Atlas. And this comet has been visible in the southern hemisphere. And there have been a lot of different kinds of predictions about what it might look like, even a prediction that's going to break apart as it gets close to the sun, and we won't see it at all. Comets are notoriously difficult to predict how bright they're going to be, and they disappoint frequently. There's a long history of comets that have been predicted to be really bright and really wonderful, and they don't pan out. But this one's looked pretty good in the last week or so. Been seeing photos from the southern hemisphere. This is our first chance to maybe see it, but it's going to be really hard. Right, you find that moon. If you can got your binoculars, probably you pull that moon out of the glow of sunrise, and then you drop down 15 degrees, 5 degrees, 10 degrees. You drop down and right from the moon about 10 degrees. Remember, 10 degrees is a fist at arm's length like that, and you might be able to see the comet. If the comet has the big tails, you might be able to see those stretching up away from the incoming sun. But that's just our first chance. It's going to disappear behind the sun, and then it'll pop back out, and we'll see. We'll see. Just giving you a heads up in case you've been hearing about that. Let's think about Saturn a little bit, too. So Saturn is now still in Aquarius, still in retrograde motion. It'll turn around a little bit. It'll turn around and start into prograde motion later this fall. And Jupiter will join it in retrograde motion before that. But so it's still retrograde. It's still moving west against the background stars in Saturn. And for this week, it sits right below a star 83 Aquarii. 83 Aquarii is about 3.5 degrees. So that's probably, 3 fingers at arm's length like that is where that sits below Aquarius. Maybe not quite, 2.5 fingers at arm's length with below 83 Aquarii. 83 Aquarii is a 5.4 magnitude star. You got good dark skies, you can see it. Barely, maybe. So I probably would never be able to see it. But you might be able to pick that out. Binoculars should pull that out, no problem at all. This is a binary star. And it's a binary star where the two stars are separated. Their apparent separation on the sky for us is between maybe 1/10 and 2/10 of an arc second. Now that's really close together. Most of us don't have the kinds of skies that allow us to pull that apart. And we don't even have the equipment that allows us to pull that apart. So this has been a real challenge for most of us. Now, if you live in the high desert and you've got a 16-inch or a 20-inch telescope, you might be able to do this. You might be able to see this as a binary star there. I see these two stars. It's got an orbital period of 22 years, and the star is 200 light years distant from us. Now, this got me to thinking, okay, I don't know anything about the history of this star. I just know it's a close binary star that's going to be really hard for most of us to go out and be able to see. So I went back to see when was it discovered as a binary star, and I found the paper. I found the paper that was announcing the discovery in the publication of the Astronomical Society of the Pacific, Volume 14, Number 86, October 1, 1902. So it was published in October of 1902 that this was discovered as a binary star, and it was discovered by R.G. Aitken. And I don't know anything about R.G. Aitken. I went to look up, and it's interesting in the paper. I read the paper quickly, and maybe I missed it. But what he said in the paper, he said, I discovered this as a binary star using the 36-inch telescope, but it didn't say where. And so presumably the people at the time knew the telescopes by size. The size of the telescope that they're talking about had different names at different observatories, but he was at Lick Observatory. So I went to find out he was at Lick Observatory. So big 36-inch telescope, bigger telescope than most of us are going to have. He said in the paper he had seen it as elongated in a 12-inch telescope. So that's more hopeful for us. Lick Observatory is outside Santa Cruz in California. And I have a little brief history with Lick Observatory. Not much of a history, but a little brief history. Back in the 90s, when everybody had gone to CCD cameras, everybody was using CCD cameras, there was still one telescope at Lick Observatory that used plates, old photographic plates. And nobody wanted to use it because of the old photographic plates, which we got to use it. And I was working a little bit, just as a side project, with Kevin Hurley there. Kevin Hurley is known for having discovered a class of repeating gamma ray bursts. And that's what we were looking for there. And I was trying to help out just a tiny bit on the project. And he was looking for follow-ups. We were looking to see if there were optical transients associated with gamma ray bursts. And there are. We now know. This is how we figured that out a few years after we were doing this work. I needed a bigger telescope, needed a faster slew time to get there, needed to be much, much, much more technologically advanced than we were going to get with these plates with the little telescope at Lick Observatory. But anyway, that's where these plates come from. You can see on there, here's what the plate looks like. It says Lick Observatory, University of California, right there. And you can see it describes what the field looks like. And you can see the plate. The old photographic plates look like this. You'd have to scan them in to see if you could see the dark object you were looking for in there. And so all of this was great until we finally ran out. These came from Kodak, Kodak glass plates. And they sent a note to us at one point and said, hey, this is the last box. We're not making them anymore. This is the last box of plates we have. And so that project ground to a halt, and it got the camera on that telescope, the 36, not the R36, the camera on that telescope got replaced with a CCD camera, and the rest of that is history. Kevin Hurley passed away a few years ago. Great guy, great astronomer. I know I've worked with him very briefly, very lightly on a project like this, again, just as a side project, but I'm a better astronomer for having had an association with him for just a brief time like that. So anyway, that's what all of that, looking up that paper and thinking about when and where this was discovered as a binary star got me thinking about all of this stuff and remembering Kevin. So anyway, what we can do then also look at here from Saturn, we can drop south, the bright star below Saturn, about 22 degrees, a couple of fifths below Saturn, straight south is Fomalhaut. And Fomalhaut, those of you who've watched this for a few years, these little shorts that I make, you know that that's one of my favorite stars because it's a big bright star. You can see it pretty far south. You can't see things. I can't see things from the mid-northern latitudes where I am that far south very much. So you drop down to Fomalhaut this way, and you go past 88 Aquarii. So 88 Aquarii is going to be a faint star about like 83 Aquarii, just off, 2/3 of the way down from Saturn to Fomalhaut, and just off to the left, just off to the east of that line that connects Saturn to Fomalhaut. Now, if you blow that up, 88 to Fomalhaut down here, that triangle like this, you go up about that same distance, and you come to NGC 7293. NGC 7293 is the Helical Nebula. It's a planetary nebula. Remember, planetary nebulae are stars, low-mass stars like the sun, that have puffed off their outer layers, and that outer layer is expanding out into space. It has nothing to do with a planet. but they can be very small if this object has just started to expand. The outer layers have just started to expand into space, and they can look a little bit bigger than stars and have a disk to make it look like they're planets. That's how they got that name. But this is a big one. Once they've expanded out a ways, they can get to be pretty big. But the trick is, as they get to be bigger, they get to be fainter and harder to see. So this was a pretty low surface brightness object. It's worth going out and trying to check it out. You got your telescope out. You don't need as big a telescope. You don't need as good a skies to be as you would to be able to pull this binary star apart, 83 Aquarii. But it'll be a good object for you. Now, before you get over there, halfway across, just below the Delta Aquarii star, Scott, that straight down from there, you'll run across NGC 7392, and that's a barred spiral galaxy. It's what I would call, maybe I'm not being fair to it, but what I would call a pretty run-of-the-mill barred spiral galaxy, a galaxy for small telescopes. But it's a very visible galaxy nonetheless, so it's worth checking it out to see if you can see these two objects as you make a triangle with 88 Aquarii and Fomalhaut over here, and look at the top part of that triangle to see if you can pull out these two deep sky objects. As the moon goes away, as the week works on, this is going to be a great time to try to do this. So that's what we got for you, everybody. We got Saturn, we got Mars and Jupiter that we've been watching, in the moon, and maybe a comet, but I wouldn't hold my breath for that one. And we've got a couple of deep sky objects in Aquarius that we're going to check out. So, as always, everyone, thanks for watching, and I hope you have a great observing week ahead.